Welcome to this explainer, where we're going to uncover exactly how a Bachelor of Engineering in Environmental Science and Technology transforms students from everyday laboratory researchers into elite corporate sustainability leaders. If you think this degree is just about planting trees or studying ecosystems, prepare to have your perspective completely shifted. We are looking at a discipline that is actively engineering the solutions to the global climate crisis and driving massive corporate strategies along the way. Okay, let's dive right into this pretty massive number, $104,170. That represents the median annual salary for environmental engineers in the U.S. right now, according to the Bureau of Labor Statistics. And actually, the top 10% in this field, they're earning over $160,000 a year. It proves a crucial point right out of the gates. Saving the planet and building sustainable infrastructure isn't just a noble pursuit, it is highly lucrative and in extreme demand globally.
So, here is our map for today. We're going to cover Engineering the Green Economy, your syllabus from fieldwork to the boardroom, real-world environmental tech, driving corporate ESG strategy, global demand and salaries, and finally, your path to impact.
Let's start with Section 1, Engineering the Green Economy.
When you look at discussions from actual professionals out in the field, a really distinct contrast emerges. Pure environmental scientists are generally the ones who identify the problems, right? They study the ecosystem, they monitor the impacts, and they basically say, hey, here is what's going wrong. But engineers are the problem solvers. They're the ones who actually design, model, and build the physical solutions that society desperately needs to move forward without steamrolling the environment.
So, this discipline isn't just about studying nature, it's about actively redesigning industrial processes. Think about massive wastewater treatment facilities, advanced emission controls, or creating totally circular resource loops. You're taking heavy quantitative design, think calculus, thermodynamics, fluid mechanics, and you're integrating that with biology and chemistry to protect human health and ecological integrity. It's a massive undertaking.
Moving right along to Section 2, the syllabus, from fieldwork to the boardroom.
Take a look at the core outcomes from the Anna University curriculum here, because it highlights a really interesting dual focus. Notice how it emphasizes both technical problem analysis and the sustainable design solutions that modern employers are practically begging for. It explicitly lists design solutions and modern tool usage right alongside society and environment. And this proves that from day one, you are being trained not just as a scientist, but as a systems architect who truly understands the societal and economic impacts of what you're building. It's kind of like a giant puzzle. Let's look at this timeline to see how it builds across your college years. You don't just jump straight into saving the world. You start your sophomore year with the heavy stuff, math, differential equations, and microbiology. Then you transition in your junior year to designing the actual pollution control systems for water and air while mastering geographic information systems. Finally, you finish your senior year mastering corporate policies, environmental impact assessments, and disaster risk management. You are literally going from micro-level data all the way up to macro-level infrastructure management.
Now, to conquer a rigorous curriculum like that, you're going to need the right resources. These are the foundational reference textbooks you'll rely on, which pop up constantly on university syllabi. Mastering complex environmental chemistry and systems engineering requires deep dives into texts like Gilbert Masters' Introduction to Environmental Engineering and Science. Let me tell you, these aren't exactly light beach reading. They are the exact blueprints you need to understand how chemical reactions scale up to massive industrial processes.
And let's be real for a second, it is not an easy path. Current engineering students will be the first to tell you that the foundational math and chemistry courses are incredibly demanding. You're tackling calculus 1 through 3, differential equations, plus organic chemistry and physics. But the ultimate takeaway is this: toughing it out absolutely pays off. Engineering alumni explicitly note that pushing through this math-heavy workload unlocks a much higher pay scale and significantly better career mobility than a pure science degree. You essentially become a highly paid problem solver.
All right, Section 3, Real-World Environmental Tech.
Advanced techniques like bioremediation and biotechnology are a huge focus here, as you can see in the UPL University syllabus. And this isn't just theoretical textbook stuff. You're translating laboratory insights directly into high-stakes industrial cleanup operations. We're talking about learning how to use living microbes to literally detoxify hazardous waste sites, or designing advanced oxidation processes to break down modern pollutants. It's fascinating.
This perfectly captures the whole concept of scaling up. You'll quickly graduate from testing tiny water samples in a beaker to managing the actual physical infrastructure that keeps entire cities and massive manufacturing plants running sustainably. Think about designing multi-billion-dollar wastewater treatment facilities, or those huge industrial air purification stacks that literally prevent urban centers from suffocating. That is the true scale of an environmental engineer's daily work.
Next up, Section 4, Driving Corporate ESG Strategy.
So you might be wondering, why are engineers suddenly calling the shots in the corporate boardroom? Well, new global regulations are mandating strict ESG reporting. That's environmental, social, and governance. Investors and private equity firms are scooping up environmental service companies left and right because they offer long-term contracts and recurring revenue. And who do they absolutely need to run these companies and do the heavy due diligence? Engineers. They need people who can leverage data to prove corporate sustainability, navigate incredibly complex carbon reporting, and integrate proprietary tech into massive mergers and acquisitions. To put that into perspective, in the UK alone, the environmental services market is generating over £35 billion annually. That massive scale explains exactly why major private equity firms and global consultancies are specifically hunting for engineers. They need professionals whose technical data analysis can directly influence boardroom strategy, secure green financing, and lead massive sustainability platforms. You aren't just an engineer anymore. You've become a vital corporate strategist.
Let's move to Section 5, Global Demand and Salaries.
Okay, let's talk numbers, because these placement records from top Indian institutions are honestly kind of mind-blowing. You're looking at 85 to 90% placement rates across the board. IIT Bombay is seeing highest packages hit 1.68 crore. BITS Pilani is at 1.47 crore. And look at the recruiters. It is not just your traditional core industrial firms like ONG and Tata Steel. It's Google, it's Amazon, it's Microsoft. Big Tech is actively recruiting environmental engineers right now for their data analytics, systems modeling, and corporate sustainability teams.
And if you're thinking about heading abroad, the global skills shortage is literally your best friend right now. The U.S. is offering average salaries from $90,000 to $150,000 with very clear EB2 and EB3 visa pathways. Canada is offering up to $130,000 Canadian dollars with fast-tracked express entry for permanent residency. And the UK is heavily recruiting for infrastructure and green tech to meet their net zero targets. The demand for these skills crosses literally every border.
There's this recent review from an IIT Bombay student that just hits the nail on the head regarding the reality of this degree. As Priyanshu knows here, the roles varied wildly, from software development to mining engineering. An environmental engineering degree gives you the ultimate flexibility. Because it teaches you how to model complex systems, you have the freedom to work in heavy industry, pivot into top-tier tech, or lead corporate ESG consulting. It's a real game changer.
Finally, Section 6, Your Path to Impact. We've seen how this degree takes you from studying microbiology in a lab to commanding multi-million-dollar salaries and leading global M&A strategies. The global demand for these highly analytical problem solvers has literally never been higher. So the only question left for you is this. Are you ready to build a highly lucrative career by designing the solutions our world desperately needs? Will you be the engineer who solves the global climate crisis straight from the boardroom? Thanks so much for joining me for this explainer, and I really hope it helped illuminate the incredible path ahead in environmental science and technology.